Hello everyone. In this video, I'm going to explain what is the meaning of the word penalize in a regression statement. The word penalize in a regression only comes when we are dealing with lesser regression or ridge regression. So the point of making this video is to understand the word penalize and how can we visualize the word penalize in a statement. So let's take the example of most machine learning cases. What happens due to the high computational power of our machines today? What happens, the data that we have given, suppose this is the data points that are given to a machine learning problem and we are trying to compute a generalized way of it. But what happens due to the high computational power, and maybe sometimes there are other factors like very less data points like we have here, where we have only 10 data points here. What happens is that the machine learning model learns the data points instead of generalizing them. What happens, see, they learn the data point and this actually results in a very poor score when it comes to testing data or the data that it has never seen. So this is kind of the situation which we call overfitting. So the reason why we need penalization is to avoid overfitting. So let's understand how the machine learning model deals with regression statement. Now we know that this is an overfitting graph, but a computer doesn't know that. A computer can only generalize the data points after seeing the cost function. Now the cost function is nothing but the predicted value minus the actual value, which is exactly this. I'll come to the next point here, which I've hidden. So this is the predicted value and minus this is the original value. You can see it's y equals to mx plus c. This is the y equals to mx part of that. So this is the cost function. Now what happens? What this leads to this situation? How? See, a computer doesn't understand what is overfitting. We can understand because we know. The computer doesn't know anything. But how does this cost function relate to this? Now what happens during the predicted value, since it has already learned the data, what happens, the predicted value and the actual value becomes same. So what happens, so this part is equals to 0, and that is the reason it points the predicted value exactly here. Same happens for most of the data points. As a reason, it goes on learning the data points instead of generalizing them. So to avoid this, we need the additional term called penalize. So to avoid making this term 0, we need to add an extra term to it, which is this part. So let us not delve into the complexity of this. Let's make this a black box like this. You just understand that this is a plus something. So this is the cost function, and to avoid making this 0, we have to add something, right? So this is what exactly this does. It makes this part non-zero. So whenever we get a 0 here, iterative function to be 0, to avoid overfitting, we add a term to it so that it diverges itself. So to understand it, what penalize actually is, to visualize what penalize actually is, what we need to do is, we can understand it like this. See, this is the generalized line, this is the generalized what it should be, but we are getting this line which is an overfitted line. So penalize means, suppose for this point, for this point, what happens when it tries to predict the value, it gets a 0 for here, but since we have a penalization term, the point moves up till here. So from here, just a second. So from here, the line gets here. Similarly for the second point, so the second point, from the line here, it gets here. For the third point, from the point here, it predicts to this point. For the fourth, it gets to this point. For the fifth, it gets to this point. The final state is where it is there. So this is what happens to the whole line. Now if we plot it all together, we get the generalized line. So this is what prevents the machine learning model from overfitting the data. This small term actually helps us. This small term actually helps us to prevent overfitting and create a generalized data. Thank you.